Hey everyone and welcome. Today we're tackling Leetcode problem 2300, successful pairs of spells and potions. It sounds a little like something out of a video game, but it's a really great problem for practicing some important search techniques. We'll break it down step by step, starting with the simple way and then moving to a much faster solution. Let's get started. Alright, let's look at the problem statement. We're given two lists of numbers, one called spells and another called potions. Each number represents the strength of that item. We're also given a single number, called success. So what do we need to do? The main goal is to figure out for every single spell in our list, how many potions are strong enough to make a successful pair. A pair is considered successful if the strength of the spell multiplied by the strength of the potion is at least as big as that success target number. The final answer isn't just one number. We need to return a whole new list. This list will have the same number of items as our original spells list. The first number in our answer will be the count for the first spell. The second number will be the count for the second spell, and so on. Okay, let's walk through the first example to make this concrete. We have our spells, our potions, and a success target of 7. Let's take the first spell, which has a strength of 5. We'll pair it with every potion. 5 times 1 is 5. Not big enough. 5 times 2 is 10. Hey, that's bigger than 7, so that's a success. And if a potion of strength 2 works, then any potion stronger than that will also work. So potions with strengths 3, 4, and 5 will also be successful. That gives us a total of 4 successful pairs for the first spell. Now for the second spell, with strength 1. Well, 1 times the strongest potion, which is 5, only gives us 5. That's less than 7, so no potions will work here. That's a count of 0. Finally, the third spell has a strength of 3. 3 times 1 and 3 times 2 are too small, but 3 times 3 is 9, which is a success. And so are 3 times 4 and 3 times 5. That's a total of 3 successful potions. So our final answer is an array with the counts 4, 0, and 3. Just a quick heads up. We'll be walking through the solution using Python, but don't worry if that's not your main language. I'll be showing the full code for other popular languages like Java, C++, and JavaScript towards the end of the video. Okay, let's think about how to solve this. The first idea that usually comes to mind is the brute force approach. It's simple and direct. We just take the first spell, and then we loop through every single potion, checking if the product is successful. We count them up. Then we take the second spell, and again, loop through all the potions. We do this for every spell. It's straightforward and guaranteed to work. Here's what that brute force approach looks like in Python. You can see the two nested loops. The outer loop goes through each spell using an index I, and the inner loop goes through each potion using an index j. Inside, we just do the multiplication and check against success. If it's a match, we increment our counter. After checking all potions for a given spell, we store the result. While this is easy to understand, it can be pretty slow if the lists of spells and potions are really large. So how can we do better? The main problem with the brute force way is that we keep rechecking all the potions over and over, but there's a pattern we can use. If a potion with strength, say 10 works, then any potion with strength 11, 12, or 100 will also work, right? So what if we sort the potions list first, from weakest to strongest? Then for any given spell, we just need to find the very first potion that's strong enough. Once we find it, we automatically know that it, and every potion after it in the sorted list will also be a success. So the question becomes, how do we efficiently find that first successful potion? Well, we can rephrase our condition. For a given spell, we're looking for a potion where the spell's strength times the potion's strength is greater than or equal to success. A little bit of algebra tells us that this is the same as saying the potion's strength must be greater than or equal to the success value divided by the spell's strength. This gives us a specific target value to look for. And what's the fastest way to find a value in a sorted list? Binary search. Here's the code for the optimized approach. First, you see we sort the potions list. Then, we loop through each spell just like before. But this time, instead of another loop, we calculate the min potion strength we need. The block of code after that is a classic binary search. It efficiently finds the index of the first potion that meets our requirement. Once we have that index, the number of successful potions is simply the total number of potions minus that starting index. Let's zoom in on that binary search part, because it's the heart of the solution. We start with a left pointer at the beginning of the potions list, and a right pointer at the end. We check the potion in the middle. If that middle potion is strong enough, great, that could be our answer. We save its index. But maybe there's an even weaker potion that also works. So we keep searching, but only in the left half. If the middle potion was too weak, then we know the answer must be in the right half. among the stronger potions. We repeat this, cutting our search area in half each time, until we find the very first valid potion. So let's compare these two methods. The brute force approach has a time complexity of big O of n times m. If both lists have 100,000 items, that's a huge number of operations. The optimized approach is much faster. Sorting the potions takes m log m time. Then, for each of the n spells we do a binary search, which takes log m time. This brings the total to m log m plus n log m. This is a massive improvement over the first approach. Both solutions use constant extra space, not counting the answer array we have to return. Alright, as promised, here is the full solution in Java. It follows the exact same logic. Sort the potions array, then loop through the spells, using a binary search for each one to find the count. You can pause the video here to take a closer look at the implementation. Next up, here is the C++ version. C++ has a very convenient function in its standard library called lower_bound, which does exactly the binary search we need. It finds the first element that is not less than our target value. This makes the code a bit more concise, but the underlying principle is identical. And finally, here is the solution in JavaScript. Again, the logic is the same. We sort the potions array, then iterate through the spells, implementing a manual binary search to find the number of successful pairs for each. Feel free to pause and review the code. So let's wrap it up. The main takeaway here is that while a simple brute force solution is a great way to start thinking about a problem, you should always look for ways to optimize. In this case, the key insight was recognizing that sorting the potions array would allow us to stop doing redundant work. This opened the door to using a much faster binary search algorithm instead of a linear scan, which makes all the difference for larger inputs. If you enjoyed this problem and want to keep practicing, the learning doesn't have to stop here. I've organized all my video solutions into handy playlists. Whether you're looking to grind through more Leetcode easy, medium, or hard problems, or you want to master a specific topic like sliding window or dynamic programming, I've got a playlist for you. It's the perfect way to focus your study sessions. Go to the playlist tab and find a playlist that fits your goals. Also, if you're looking for even more Leetcode problems beyond the daily challenge, I've started a second channel called Leetcode Unlocked. It's where I'll be posting solutions to a ton of other problems. So if you're serious about your interview prep, be sure to check it out. The link is in the description below. Hope this Leetcode solution breakdown made sense. If it helped, give that like button a click, maybe subscribe for more, or drop a comment if you have questions. Make sure to turn on the notification bell so you know straight away when I upload a video, because I upload videos daily. This channel doesn't make any money from sponsorships or ads yet, so if you're feeling generous, there's always the Boba Fund. Keep coding, and I'll catch you in the next one.